This video is just basically first talking about what is refraction for a start. So I'll open up the simulation so we can see what's actually going on. So by clicking on that simulation, we've got a few different things we can click on. I usually go to more tools because you can just do more things there. And we notice that when I shine a light, we do get some reflection, but we're not interested in the reflection. We're interested in the refraction. Refraction is when light goes it goes from one substance into another. Now, this substance can be thought of as a medium. So I'm just going to label that now. So this is, we could call this a, I don't really like this pen. I might just use zoom instead. Let me just change that. Right, so I'll just click zoom annotate. Okay, so I'll try that again. Right, so that's a medium, and in this case, the medium is air, and over here, the medium is glass. The reason why that is because it says glass there, and this one says air. Okay. Now, in this case, that angle is called the angle of incidence, which I'll label as I. Now, on your ray diagrams, you must say what direction the light is going. In this case, it's a laser, so it's going from the laser and it's going down to somewhere else. So we'll point the arrow like that. The reason why I bring that up is because this could be a ray diagram of somebody seeing light. And so that could be an eye, and the light be coming from over here. So in that case, you do that. Okay? So that you must draw must draw what direction it's going. And in this case, because it's coming from the laser, then we are getting some reflection which goes back that way. Otherwise, you'd get reflection going that direction if it was coming from underneath. So that's the angle of incidence, and then this is the angle of refraction, which we can label as R. Now, this is where it gets a bit confusing, because if you're looking at reflection, not refraction, you would label this the angle of reflection, and you'd probably label that as R as well. So you usually don't look at both of them at the same time. So we're just going to look at refraction here. So essentially, refraction is when light goes from one medium into another medium and it changes direction. It might move towards the normal. This is the normal here, this dotted line, or it might move away from the normal. And I would say for now that the reason for that is related to its speed. So if I were to get this speed thing here and measure the speed there, we can see that it is, if I just line it up properly, it's being a bit irritating. Oh, come on. Right, 1c. In other words, so c is the speed of light in a vacuum. It'd actually be slightly lower than that because it's not in a vacuum, it's in air. But in any case, that's the value, that's how fast it's going. Whereas once it's traveling in glass, it's actually traveling a little bit slower than that, so 0.67 c. So it seems that, and then over here, it would be saying c again because it's just reflected, traveling through air. So it seems that when light slows down, it moves towards the normal here. So this is what we're going to try to understand now, okay? Is that the case, and why would that be the case? When light slows down, it moves towards normal. Just so as I'm clear about what do I mean by moving towards the normal, this dotted line is the normal, and it would have gone that direction, but it's not. The line has moved this direction, which is towards the normal. Okay, so it could have moved away from the normal, and it could have gone over here. But it didn't. It moved towards the normal. So it seems that when light slows down, it moves towards normal. Actually, that is the case. When light slows down, it moves towards normal. So we're now going to understand why. Okay? So why does it move towards normal?